Hey guys, welcome to our first video lesson. Today we're going to be doing Skittles probability. This is independent versus dependent probabilities. These notes are linked on Google Classroom, so you can follow along with them as you go. Today, to help me out, I have my assistant, Jansen Grunwald. Say hi, Jansen.
Hello.
There he is. He's going to help me out with some numbers. You can see I already started to fill out some of the numbers. So here we go. So independent, dependent probability, independent events do not affect each other. Dependent do affect each other. How many total Skittles there, Jance?
We have 44.
Okay, now we're going to go through. We have how many orange?
11.
How many yellow?
6.
Red?
7.
Purple?
11.
And green?
9.
All right, so we're going to first find the simple probabilities by looking at the number of each color divided by the total number of Skittles. So orange was 11 over 44. Yellow is 6 over 44. Now, some of these can be reduced. Boy, you don't have to reduce them. Our red is 7 over 44. Purple is 11 over 44. And red and green is 9 over 44. Those are our probabilities. That's called simple probability because there's only one action going on. Okay? All right, so here we go. If you recall from Friday, we're using the fundamental counting principle. That word and is going to mean to multiply. So this first round, we're doing independent probability. That means the one we choose the first time has no effect on what happens on that second time. All right? So if I look at my green Skittles, the probability of getting a green Skittle, if I scroll back up, was 9 out of 44, right? 9 over 44. So I want to choose a green and a green. With replacement means after I pick it up, I'm going to put it back in. After I pick it up, I'm going to put it back in. So we call that an independent event. That means we're not changing the amount of greens or the total amount of Skittles after each time we pull one out. Okay. So our first one, green and green. Now recall, our simple probability of getting a green was 9 over 44. I'm going to multiply that times 9 over 44. And I got a calculator standing next to me. So I'm going to do 44 times 44. So that is equal to
1,936.
Nailed it. Okay. So we have 81 divided by 1,936 is our probability of getting a green and a green. So you're going to multiply each of the simple probabilities. Okay. I want you to pause the video and do the following. Check your answers, and the things you should notice about all of this, the denominators, is that they're all 44. That's because we did not change the probabilities as we went. We're taking one out, put it back. Take it out, put it back. So the probabilities stayed the simple probabilities the entire time. We're going to move on now to what we call dependent probability. Okay, this is we are going to take the Skittles out, and someone is going to get to eat them. All right. So here we go. We're going to do green and green. So this kind of probability is called dependent. All right, because the amount of Skittles left will depend on what we do. All right. So first, let's go over the first part. Okay. We're going to find the probability of getting a green and another green. So right now, Jansen, how many green are there?
What?
How many green are there?
9.
Out of?
44.
All right, so that is our probability. We're going to start there. 9 out of 44. Okay, take a green. Oh, nice. Now, how many green are there?
8.
How many total Skittles are there?
43.
All right, so those are our two probabilities. Let's see, the first green is 9 out of 44. That's what we started with. Then the second green is 8 out of 43 because we took one green and one of the total amount of Skittles
We have
away.
more Skittles after this.
Okay. After we multiply our two probabilities together, we're left with 72 out of 1,892, and we can reduce that, right, to 18 over 473. 18 over 473 is our probability of getting a green and a green without replacement. Okay. All right, we're going to do one more together, then you're going to try to finish the rest. So our probability is constantly changing. So we right now, did you eat the second green?
What? Oh.
So our green has gone down by 2, and our total has gone down by 2. So our green started out with 9. We only have 7 green left. Do we eat any orange yet, Chance?
No.
All right. So our probability of getting orange right now, there's 11 orange, because that's how we started with. We started out with 44. We ate 2 Skittles. We're down to 42. Okay? So give an orange to Colby. Colby's here.
No.
All right, eat an orange. All right. So we ate an orange, so we no longer have 11 orange. But now we have 7 green remaining. We ate another one, so we're down to 41 Skittles. Okay, so we're going to multiply our two probabilities. And 11 times 7. Okay, and that is our probability of getting a orange and a green. And you're going to see that the denominators are going to constantly change as we go here. So if I divide both by 7, I'm left with my simplified probability. Okay, pause the video here, try these out. Your denominators should be changing as we go. We're going to continue to find the dependent probabilities and eat the candy. It's going to be a lot of fun. Let's check out your answers. There are both the unreduced and reduced probability fractions as we go. Okay, Colby wanted to get in on this too. What you'll notice is that the denominator kept going down because we kept eating the Skittles. Okay, and you'll see that each time it went down by 1. Right? That is called dependent probability because the probability of each event depended on what we ate on the previous event. Okay, Chance, did you like this one?
Yeah.
Why?
Because I like to eat Skittles.
All right, great. Well, guys, go do the problems. Check the video again if you need to, and also you can check the answer key we posted on Google Classroom. Again, if you have any questions, please email me. Talk to you soon.